Right, hello, my name is Joe. For my project I've done a steganography tool, which I will demonstrate. So to start off, this is just a welcome form, and it obviously just lets you go about. You have a about, which is sort of like a tutorial, exit, and then these three are the main three things, mainly this one and this one, really. So this is for this is for text, embedding text into an image. So you begin up here, and you need to pick your cover image. So I've just been using this one, but you can use literally any PNG, JPEG, BMP, and basically anything, as long as it's an image and it's not a GIF, then you're alright. So once you've opened your image, you need to write some text in. So we'll just put that, and then you have the option to encrypt, but it's not mandatory. And I've included Caesar and symmetric, and the Caesar one just shifts everything up 2 places in the alphabet, and then obviously when you decrypt it, it shifts it back. But before you decrypt it, it looks kind of like that. So you can see here H has turned into J and E has turned into G, because it shifts 2 places up the alphabet. So if we just get that back again, then the other one is symmetric. So in here basically you've just got to type in a 8-digit passcode, which has got to be all numbers. Any 8 numbers, and then you can encrypt it. So then you've got this. Now the main part of the program is right here, this little 1 2 3 4, and as it says here, less bits equals, well, you can read that. So we'll start off, we'll just use for LSB, which I'm not going to go into too much detail about how this actually works, because I do that in my report and it'd take me too long, and obviously I'm on a time limit. So we click for LSB, which basically means if there's 8 bits in a byte, then we're using up 4 of the last 4 bits. So just sort of as a reference, this is for LSB. As you can see, it's a lot more noisy, if that's a word. Much more noise in this image than there is to this image, and yet all of these images are totally filled with text. And it changes, so it allows you to change 15 out of 255 of the colour of the image. But as I say, I go more into that in the report. So if we click embed, by the way, that actually should have been taken out, but I forgot. And this is exactly what I've submitted, so just thought I'd leave that in. So now we've embedded it. As you can see, no change, because this is tiny. So then if we save that, I've just got them all saved as this, but it doesn't need to be saved as anything. This is just so I don't overwrite my original colour scale image. Yep. So now what I'll do is I'll actually close the whole program down and reopen it. Go back into here, and then we'll open up the saved image, the stego image here, and then choose as for LSB. Then we click decode, and we get as encrypted text back. Okay, so I just had to stop the recording there because I forgot the key. So now we have the key, and if we click decode, and get this text back from where we saved it. Then now we can use this decrypt button and as key. So if the key's wrong, then this will not decrypt correctly. So we've inserted this key, click decrypt, and we get back this message. So that is all stored in here, obviously. But well, this is stored in here. This text here is stored in here. Then we can decrypt it, and then we've revealed the original message. So one problem that I had with the text embed was on 1, 2, and 3 LSB, because there's 8 bits in each byte, and if we only need to use 3 bytes to start on, say if we're using 3 LSB and we're putting in A, the letter A, so that's 8 bits. So we get the first 3 bits, put them in R of the first pixel, R for red. We get the second 3 bits, put them in the G for green of the first pixel, and then the blue, we only need 2 of those 3 bits in the blue value. So the effect that this has is that it takes the 3, and then the final character, so this character right here, can sometimes be a little bit distorted. But if sometimes it isn't, sometimes it isn't. If it uses the full pixel, then it's not. So we'll just do the same thing, but we won't encrypt it this time. And I use 3 LSB, right? And then we'll save it. And then when we click decode, you can see here the final character has actually disappeared there. So that's not ideal. When it disappears, that means that because it gets converted into ASCII, and then the ASCII number gets converted into binary, and then that's how it gets added onto the end of the pixel color value. So if it's something that is not recognized in ASCII, so if it's not a character, remembering that it takes the 1 extra digit, then it'll just come up as nothing. So if we use 2 LSB, it should come back with something different on the final pixel. We just save that. Yeah, and then there you can see, so we've got a little hashtag there. But that is only ever on the very final pixel, and it's because of how I've stored my length, which again I'm not really going to go into because it would take too long to explain on here, but in my report I cover all that. And that happens with 1, 2, and 3, but not 4. 4 is usually safe. So that is basically the text embed. That is the main thing, definitely. This here, it sounds quite simple, but it's really not that simple. Like, this is all the text for the embed. The 4 different methods for the embed. So yeah, I think I've pretty much covered that. The Caesar, if you encrypt it, as I say, it just goes up. It goes up 2 places, and then when you decrypt it, it goes back down. So actually, if we just copy and paste that into here, and we decrypt it, and as you can see, it goes back to its original text. So that's that. And then the image embed, very sort of similar idea. So the image embed is only 1 LSB, meaning for every byte you want to use the very last bit. So the cover image needs to be 8 times larger than the image that you're trying to put in. So say for example, I'm going to put this Carl Sagan image, which is 50 by 50. So the cover image needs to be at least 400 by 400, And as you can see here, we've got 600 by 388, so that should be okay. And then we've got a Carl Sagan image. So now if we click embed, as you can see, you would never suspect that this image is actually starred inside here. So now if we save that, just save it here, then we have, it automatically goes to there, or you can put your own in. And then if we click decode, we have a stego image and the image extracted. So then you can save as or whatever you want to do. So again, this image here and this image here, which is the same, but this is zoomed in because it won't fit in the box. This image here contains that image, and you can just extract it using this, but as I say, you'd never know that that's in there. And again, because it's 1 LSB, it's 1 in 255. The RGB value of each pixel changes by 1/255th, or whatever, or you know. So yeah, that's that. And then compare results. This actually were never even. This were more. I wrote this code just sort of to test if the images were actually changing or not, and to sort of compare the differences. In my report, I did I compared other people's apps, which you can again read about in the report, but this is just a thing I did to sort of measure the difference. So hang on. So if we open up this one, which as you can see again, I don't know if this is going to be compressed or whatever by YouTube, but as you can see here, this image is all noise. So then if we click compare, you can see the effect of the noise here. Or I can anyway. I don't know if YouTube is going to compress this. I don't know how it's going to compress it, so yeah. And then you could save that, but just, you know, again, this is more like this is just included because I wrote the code and I just thought it were a pretty cool little thing to sort of validate, no, to check the difference really. So that's that. The about, just a little tutorial, little textual tutorial, and then exit. You know, any unsaved work will be completely destroyed. The UI is all. This is not typical Windows Forms UI at all. This is a panel with a label and a button. Yeah, I think that's about it. Thank you for watching.